Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 11.4, definition of derivative. Now when we're doing these, we talked in section 11.3, the slope. That's called the difference quotient. It's the slope of the secant line, average rate of change, average velocity, average rate of cost, revenue, or profit. If we're finding the average rate between two values, it's your difference quotient. The derivative, which is what we were doing also, the limit part, so it's at 1 point, that's the slope of the tangent line, instantaneous rate of change, instantaneous velocity, marginal cost, revenue, and profit. When you see these words, then you want to use this one. Another thing you know is that you're only given one value here, A. Here you're given A and B, so that also helps you remember. Okay, let's look at a couple graphs. These are slopes of the tangent line because it only touches at 1 point. You can use that slope, and we would just count them. So they're both going by 1. You pick a point and you count. So if I go from here, it goes up 2 and over 1. So my slope would be 2 over 1, or 2 for that tangent line. Notice it's increasing, so it's going to be positive. This one's decreasing, so it would be negative. And if we pick 2 points, looks like this one, down 1 over 1. So that looks like that works. So this slope of this line, down 1 over 1, is 1 over 1, but we're going down 1, so it's negative 1 over a positive 1. So our slope is negative 1. Look at this one. It's horizontal. When you have a horizontal slope, it's 0. Notice this is also a min. When you're trying to find your mins and your maxes, that's where your slope is 0, the slope of the tangent line. This one's a vertical line. When you have a vertical line, the slope is undefined. Okay. For the derivative, there's also what's called a 4-step process. The first thing you do is find f of x plus h. And then you take f of x plus h minus f of x, so minus the original function. Then we divide by h. Lastly, we take and let h approach 0, or find the limit as h approaches 0. Now, if you can do this all at once, that's fine. Some problems are easier to do that, but larger ones, polynomials that can reduce first, you might want to follow these steps. So let's try a couple. Move this back up. F of x equals a negative 4x squared plus 9x plus 2. So we want to find the limit, or we'll do it in steps. This one easier in the 4 step. F of x plus h. So we have negative 4 times x plus h squared plus 9 times x plus h plus 2. First thing we need to do is FOIL this. Remember, x plus h squared is x plus h times x plus h. We could distribute these. So we have to FOIL this. If you FOIL it, you get x squared plus 2xh plus h squared. And then distribute the 4. Negative 4x squared minus 8xh minus 4h squared plus 9x plus 9h plus 2, and we have no like terms. Bringing down that. So that's x plus h. Now we want to take that x plus h, and we want to subtract f of x. So we get negative 4x squared minus 8xh minus 4h squared plus 9x plus 9h minus 2. And then we're going, whoops, that one's a plus 2. Subtract the original negative 4x squared plus 2x plus 2. Now the part and the quantity, those should cancel, but you need to distribute. So if we make this a plus, that makes this a plus, this a minus, and this a minus. Notice we have a plus 4x squared cancels with this one, so this cancels with this. The 9x is negative now, and it cancels with them. The minus 2 cancels with the positive 2. If these do not cancel, then you did something wrong here. And the terms that are left should all have an h in them. So we take f of x plus h minus f of x. We get negative 8xh minus 4h squared plus 9h. So that was the second step. The third step is to take that answer and divide by h. Because then we're going to take the limit as h approaches 0, f of x plus h minus f of x all over h. Oops. Oh, yeah. So I want the limit as h approaches 0. Now, before we do that, notice if we plug 0, and we're going to have 0 in the denominator, we have 1, 2, 3, 4 terms, and they all have h's in them. So we can get rid of one h in each. If we get rid of one h in each, we're left with a negative 8x, a negative 4h plus 9. Now we can plug our 0 in. We have negative 8x minus 4 times 0 plus 9. So our derivative is negative 8x plus 9. In chapter 12, we'll be able to go, I'm losing my voice, we'll be able to go from this straight to this. But you do need to learn the process first. 2 more, a fraction and a square root. So if we have f of x equals 3 over x, we want to find f of, this one is a good one to just do all at once. Limit as h approaches 0. Plugging it in, x plus h, we'd have 3 over x plus h. Subtracting the original, x, all over h. It doesn't look pretty. But what we can do is multiply 1, 2, 3, all three terms by the denominators. So if we multiply by x times x plus h, don't multiply the bottom out, leave it factored because we want to get rid of this h. The first one, the x plus h's cancel and leave 3x. We're not going to touch the bottom. And then the next one, the x's cancel, and you can distribute the -3. I use negative because of this minus. So -3 times x is a -3x, -3 times h is a -3h. Notice my 3x's cancel. So we have a -3h over hx times x plus h. One term on the top, one term on the bottom. Cancel those h's. Keep bringing your limit down. Now that we canceled that original h that was in the denominator, you can plug your 0 in for h. Remember, it's just h. So it's -3 over x times x plus h. And in place of the h, put your 0. -3 over x times x, which is x squared. Again, this is another one where in one step you go from here to here. Let's try one more, a square root. So we want the limit as h approaches 0, f of x plus h minus f of x over oh my gosh, of just h. I wanted to put more than one term in the bottom. Okay, so plug it in. First, I would do this one all at once also because you really can't simplify until it's all together. So f of x plus h is just the square root x plus h minus the original function all over h. Again, if you plug in 0, you're going to get 0 over 0. So you need to simplify. When you have radicals, you multiply what's called the conjugate. It's the same quantity except the opposite middle sign. And what you do to the bottom, you have to do to the top. But don't multiply the bottom out. When you multiply by the conjugate, what's nice is you don't need to worry about the middle terms because they will cancel. So you only have to multiply the first two and the last two. And square root of x plus h times the square root of x plus h is just x plus h. The square root of x times the square root of x is just x. And a negative times a positive makes it a negative x. All over h times the square root x plus h plus the square root of x. Notice the x top cancel. Then the h's will cancel and leave a 1 on top. Now that canceled, you can plug your 0 in. 4h. 1 over the square root of x plus 0 plus the square root of x. The square root of x plus the square root of x is 2 square root of x. And this is one of the few times you're allowed to leave the radical in the denominator. And I think that is everything for 11.4.